Great, so we are going to start off Math 026 Module 3 Part 2, looking at the square root principle. We'll also look at completing the square and solving complex quadratic equations in this section. So the first thing we're going to look at is solving using the square root principle. And the square root principle states that if x squared is equal to c, where c is any real number, then x is equal to the positive and negative roots square root of c. So basically what they're saying is to unsquare a variable or a number or something, you take the square root of it. So if we were to solve here x squared equals 121 using my square root principle, what I'm going to do is I'm going to take the square root of both sides, and then my answer will be simply x is going to be equal to, now in this case 121 is a perfect square, so it's going to equal 11, but it's not going to equal just positive 11, it's going to equal positive or negative 11. So we look at two roots here. For b, we have x squared equals 18, and again I can take the square root of both sides, so I end up with x equals positive or negative square root 18. But if you can simplify it, you do want to simplify that radical. And I do know that I can break that down into the square root of 9 times the square root of 2. So that's going to end up giving me x is equal to positive or negative 3 square root 2 for our final answer. Okay, so now to use our square root principle, the first thing you want to do is isolate that squared term. So we're going to isolate x squared here first. So it's almost like we're solving kind of like a linear equation. We're getting x squared by itself. I'm going to start by adding 15 to both sides. And that will give me 5x squared equals 15. And then I will divide both sides by 5. So it gives me x squared equals 3. And now to find x, we will use that square root principle. So we'll do the square root of both sides. And it will give me x equals the positive or negative square root of 3. We can't simplify that, so we're done. Here again, we need to isolate the x squared. I'm going to move the 4x squared over to the other side since it's on both sides. So we're going to end up with 2x squared minus 10 equals 6. Then let's add 10 to both sides. So now I have 2x squared equals 16. Divide both sides by 2, and we get x squared is equal to 8. So now we have isolated that squared term. We're going to take the square root of both sides. So we have x squared equals the square root of 8. Or x squared, and it's positive and negative, equals positive and negative square root 4 times the square root of 2, because we can break it down. So it's going to be x squared is equal to positive or negative 2 square root 2. Okay, so now here for e, we already have our squared term separated, but at this time it is an expression. So we are going to go ahead and take the square root of both sides. So we'll take the square root of the squared term and the 3. So now we have x plus 6 is equal to the positive or negative square root of 3. And then we do want to solve for x. So what we have to do here is one more step. We're going to subtract 6 from both sides. So our final answer will be x is equal to negative 6 plus or minus the square root of 3. Let's see here. For f, it's the same type of problem. We already have the squared term isolated. So we're going to take the square root of both sides. And that will leave me with 4x minus 5 is equal to the positive or negative square root of 6. I'm going to add 5 to both sides. to simplify or divide, not simplify, but isolate the x, sorry. So we end up with 4x is equal to 5 plus or minus the square root of 6. And then the last thing we need to do is we need to get x by itself by dividing by 4. So we'll divide everything over here by 4. And we get x equals 5 plus or minus the square root of 6 over 4. If we could do some simplifying, we would break it up into two fractions, but we really can't do any simplifying, so we're going to leave it as is. But again, if we had to break it up, like what it would look like broken up, it would be 5/4 plus or minus the square root of 6 over 4. And then we could do any simplifying that we could do. All right, the next thing that we're going to look at is completing the square. And what completing the square is completing the square is basically creating a perfect square trinomial. So we can take any trinomial and turn it into a perfect square trinomial by doing the completing the square process. What we need to do to complete the square is first you want your quadratic equation, make sure it is in standard form, so ax squared plus bx plus c equals 0. And then we're going to move the constant or the c term to the other side. So we are going to rewrite it, move that c term over to the opposite side, or to the side where the 0 was. And then to create our perfect square trinomial, we are going to add b divided by 2 squared to both sides. So we're going to take the coefficient of the x term, b, divide it by 2, and then square it. And we will add that to both sides. Then we should be able to factor that perfect square trinomial and then use our square root principle to solve it. So it seems a little difficult, but it's not bad, I promise you. And we're going to take a look at it. One other thing to note, when we do our perfect square trinomials, we want the equation, we want to eliminate that a term. So if it's anything other than 1, we will divide it out first, which can make for some messy stuff at times, but it still works. Okay, so we are going to start with a. And a, notice it's already written in the form of x squared plus bx equals c. So they already moved the c term over for us, which is kind of nice. Now what we are going to do is we're going to take that b term. B is equal to 4. So we are going to do b divided by 2 squared. So 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared equals 4. So in this case, it gives us the same thing again, but that's okay. And we are going to be adding that, and I'm going to go ahead and erase that, so write it down if you need to. We are going to be adding that to both sides of our equation. So now I have x squared plus 4x plus 4 equals 15 plus 4. So the 15 plus 4 will give me 19. And then x squared plus 4x plus 4. Perfect square trinomial. The square root of x squared is x. The square root of 4 is 2. So we can factor that to x plus 2 squared. And now if you look at this, it looks exactly like it did with our square root principle. So we are going to take the square root of both sides, and we'll end up with x plus 2 is equal to positive or negative square root 19. And then we will subtract 2 from both sides. So x is equal to negative 2 plus or minus the square root of 19. And that's it. We completed our square. B, again, is already set up for us where they moved the c term over. So now we need to take our b term, divide it by 2, and square it. So b is negative 12, but the sign really doesn't matter because we're squaring it. So if we take negative 12 divided by 2, we get 6, negative 6. And if we square negative 6, we end up with 36. So I'm going to add 36 to both sides. We're going to have x squared minus 12x plus 36 is equal to negative 28 plus 36. And now we're going to simplify everything. So we will have on the left-hand side, perfect square trinomial, we have a minus and a plus. So when we factor it, it's going to be x minus the square root of 36 is 6. So x minus 6 squared is equal to a positive 8. And now, use our square root principle. We're going to divide both sides, or not divide, take the square root of both sides. And x minus 6 squared becomes x minus 6. It's going to be equal to positive or negative square root 8. And then we will add 6 to both sides. So now we have x is equal to 6 plus or minus the square root of 8. And then one thing we should do is that radical, the square root of 8, we can break it down into the square root of 4 times the square root of 2. So our final answer will be 6 plus or minus 2 square root 2. And that 2 came from the square root of 4. So you do want to break it down if you can. All right, so here we have our trinomials in standard form. So we do need to first move that c term over. So I'm going to start off by adding 9 to both sides. So we're going to have x squared plus x is equal to 9. Now my b term here is equal to 1. So we're going to do 1 divided by 2 squared, which 1 divided by 2 is 0.5 or 1/2. And 1/2 squared is equal to either 1/4 or 25/100, which sometimes the decimal is a little bit easier in this case. So now I'm going to add to both sides. I'm going to have x squared plus x plus 25/100 is equal to 9 plus 25/100. And we're going to keep going from there. We're going to simplify. Now, here's a little hint. Whenever you are going to factor this, whatever you got when you take b and divide it by 2, that's going to be what you're going to get when you factor. So I had 1 divided by 2, which is 1/2 or 0.5. When I go to factor this, the square root of 25/100 is 5/10. So it's going to factor to x plus 5/10 squared. And it's going to equal 9 and 25/100. So now we're going to take the square root of both sides. And that will give us x plus 5/10 is equal to the positive or negative square root of 9 and 25/100. And when we go, we're going to move the 5/10 over. So I'm going to subtract 5/10. And my final answer is going to be x is equal to negative 5/10 plus or minus the square root of 9 and 25/100. And 9 and 25/100, even though they're both perfect squares separately, together as a decimal, it does not make for a perfect square. So we are going to leave it in that format, and there's no simplifying we can do. Okay, so now for D, we are going to start by subtracting 1 from both sides to isolate or remove that C term. So now we have x squared minus 7x equals negative 1. And we're going to take our B, so negative 7 divided by 2, and then square it. So negative 7 divided by 2 will give me 3.5, negative 3.5. But when you square that, you end up with 12 and 25/100, so 12.25. So we are going to add that to both sides. Negative 1 plus 12.25. So that will give us, when we factor, again, the square root of 12.25 is 3.5. It's whatever you get when you take that b term and divide it by 2. And because this sign's a minus, we're going to factor with a minus. So minus 3.5, x minus 3.5 squared is equal to negative 1 plus 12.25 will give us 11 and 25 hundredths. Take the square root of both sides. So we will end up with x minus 3.5 is equal to positive or negative square root 11.25. Then we got to isolate x. So we are going to add 3.5 to both sides. And that is going to give me, let me make this a little bit neater here. X is equal to 3.5 plus or minus the square root of 11 and 25 hundredths. Okay, so now we're going to look at E, and E is one of those cases where I said we really want a squared, or x, the x squared to be by itself with the coefficient of only 1 before we complete the square. So what we're going to have to do first is take and divide everything by 3 to get rid of that coefficient with x squared, make it into a 1. So when I divide by 3, I end up with x squared plus 2x equals 4/3. And now we're going to add, b is 2. So 2 divided by 2 squared is going to give me, 2 divided by 2 is 1, 1 squared is 1. So we're going to do this. We're going to have x squared plus 2x plus 1 is equal to 4/3 plus 1. Now, when I'm adding that 1 on the right-hand side, remember, instead of a whole number 1, I'm going to turn it into a fraction. And 1 is equivalent to 3/3, because I want 3 as my denominator, so I can add them. So I'm going to end up with, if I factor x squared plus 2x plus 1, it's going to factor as x plus 1 squared. And that's going to equal 7/3. Now we're going to take the square root of both sides. So we'll have x plus 1 is equal to positive or negative square root 7/3. Subtract our 1 from both sides. So we end up with x equals negative 1 plus or minus the square root of, and I am going to switch this up a little bit. I'm going to break it up and make it the square root of 7 over the square root of 3. Because one thing that we do need to do before we finish this is we don't want that radical on the bottom. So we do want to rationalize that denominator by just taking this and multiplying it by the square root of 3 to get rid of that radical. So my final answer when I rationalize my denominator will be negative 1 plus or minus the square root of 7 times the square root of 3 will give me the square root of 21 on the top. And the square root of 3 times the square root of 3 will give me 3 on the bottom. So you do want to make sure you rationalize that denominator if it ends up with a radical in the denominator with a fraction. All right, let's see here. F is one that's similar to E. Again, we have that term in the A spot other than a 1. So we're going to divide everything by 5, and then we'll move C over. So we'll end up with x squared minus 4x minus 3/5 equals 0. But then again, I need to move C, so I'm going to add 3/5 to both sides. So I have x squared minus 4x, and I'm going to leave a spot so I can add my b term, is equal to 3/5 plus, all right, b is 4. So if we take 4 divided by 2, even negative 4, and divided by 2 and square it, negative 2 squared is equal to a positive 4. So we're going to add that together. When we factor the first part, it will give me x, I forgot my x there, get the eraser, x minus 2 squared is equal to, now again, 3/5 plus 4/5 or 4, I want to convert it into a denominator of 5. So if I make it 4 over 1 and I want a denominator of 5, it means I multiply that by 5 and I multiply that by 5. So we're adding together, let me put it in red right here, 3/5 plus 20/5, which is the same as 4. And that's going to give me 23/5. So again, we're dealing with some fractions, but it's not bad. Let's go ahead and take the square root of both sides. I have x minus 2 is equal to the square root of 23 over the square root of 5. And I'm just going to go ahead and split it up because I know I'm going to need to rationalize. Don't forget your positive and negative roots. And then we're going to add 2 to both sides. So right now we have this. We have 2 is equal, or x is equal to 2 plus or minus the square root of 23 over the square root of 5. And then again, to rationalize that denominator, let's multiply the fraction by the square root of 5 times the square root of 5 on the top and the bottom. So it's going to leave me with x is equal to 2 plus or minus 23 times 5 is 115. So the square root of 115 over the square root of 5 times the square root of 5 is equal to 5. So that's our final answer there. So in previous classes, we solved quadratics. We solved them by factoring using the quadratic formula and sometimes looking at graphing. We also talked about the discriminant. And if you recall, the discriminant is in the quadratic formula, it's the b squared minus 4ac, the part that's under the radical. And if you do the discriminant, if you calculate it, if I add, or if I get a number that's greater than 0, my discriminant is a positive number. That means that there are 2 real solutions. So the graph is going to cross that x-axis twice. If it is equal to 0, if the discriminant is equal to 0, that means there's 1 real solution. And then if I get a negative number for that discriminant, it's like having a negative under a radical. And we don't like that. Remember, before we said there was no real solution. But it does mean that there are 2 complex solutions. And remember, with the complex solutions, we deal with I. So that is what we're going to look at here. We're just going to review solving quadratics and dealing with I with them. So the first one that we are going to do is we are going to solve using our square root principle to start with. So I am going to move this up just a little bit, I think, so that we have a little bit more space. All right, and let's start. We'll start by just taking the square root of both sides of a. So we get x is equal to, right now it is the positive or negative square root of negative 16. But I know I can simplify that to the positive or negative square root of, or not square root, but 16 is a perfect square, and then you can pull out that I. So positive or negative 4i. All right, for B, we're going to do a little bit of work here. First, let's get our x values, our x squareds together. So we have 9x squared plus 12 is equal to 0. Let's subtract 12 from both sides. So 9x squared is equal to negative 12. And then we are going to take our 9x squared is equal to negative 12, divide everything by 9. So now I have x squared is equal to, and I can simplify negative 12 over 9. I can pull out a 3, so it becomes negative 4/3. And now we're going to take the square root of both sides, and we'll end up with x is equal to, and again, I'm going to break up that fraction, the square root of negative 4 over the square root of 3. And we need our positive and negative roots there. Now, I know the square root of negative 4 is equal to 2i, and we still have that square root of 3 on the bottom. But again, Do we like a radical in the bottom? Hopefully you're shouting at me. You're like, no, we have to rationalize the denominator. And you are correct. So we're going to multiply by the square root of 3 on the top and the bottom. So that is going to give me, keep our positive and negative roots in there. I keep forgetting them. The square root, or x is equal to positive or negative 2i square root 3 over 3 for our final answer there. All right, so here we're going to practice our completing the square method again and looking at our complex solutions. So we will subtract 28 from both sides to isolate or move that c term. We will have x squared plus 10x equals negative 28. And then b is 10, so 10 divided by 2 squared is 10 divided by 2 is 5. 5 squared is 25. So we're going to add 25 to both sides. And that will leave us, when we factor, x plus 5 squared is equal to negative 3. Then we're going to take the square root of both sides. So we get x plus 5 is equal to positive or negative square root 3. Oh, negative 3, excuse me. And subtract 5 from both sides. So x is equal to negative 5 plus or minus. And then instead of the square root of negative 3, remember, excuse me, you want to move that I out, move that negative 1 out. So we're going to make it I square root 3. And that will be our final answer. All right, now for B, they did isolate C for us, or move it to the opposite side. But we do have an A value, so we are going to divide everything by 2. And that's going to leave us with x squared plus 3 halves x equals negative 7 over 2. Oh boy. Okay. So now we are for B going to be doing, B is 3 halves. So we'll take 3 halves, divide it by 2, and square it. 3 halves is the same as 1.5. 1.5 divided by 2 is equal to 3/4. And if you square it, we end up with 9/16. All right, so again, 3 halves divided by 2 is equal to 3/4. And when you square 3/4, you get 9/16. And you can use a calculator to help you. So we have x squared plus 3 halves x plus 9/16 is equal to negative 7 halves plus 9/16. Let's see here. When we add those, the one side, the left side, when we factor it, it's going to be x plus 3/4. Because again, you take the square root of the 9/16, and that's 3/4 squared, is equal to negative 7 over 2. To make it so I can add it to the 16, negative 7 over 2, if we turn it into a denominator of 16, we're going to multiply the top and the bottom by 8. Negative 7 times 8 is going to give me my, 56, negative 56. So negative 56 plus positive 9 is going to give me negative 47/16. Again, not beautiful, but it's still doable. We'll take the square root of both sides. So we're going to have x plus 3/4 is equal to positive or negative square root. And again, I think I am going to go ahead and split it up because we might need to rationalize. The square root of negative 47 over the square root of 16. And then we'll subtract 3/4 from both sides to isolate x. So we end up with x is equal to negative 3/4 plus or minus. Now I'm going to do some simplifying here. The square root of negative 47 is the same as I over the square root times the square root of 47. And the square root of 16 is 4. So we can simplify that pretty easily. And there is our final answer. So it wasn't too bad. We did deal with fractions. We had to remember how to work with them, but it wasn't horrible. All right, and the last two that we are going to do here, we're going to use our quadratic formula, which if you recall, the quadratic formula is, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So for a is 12, b is negative 4, and c is 5. So when we substitute it into our equation, we're going to have x is equal to, b is negative 4, so the opposite of b will be 4, plus or minus the square root of b squared will be 4 squared, or negative 4 squared, minus 4 times 12 times 5, all over 2 times a, or 2 times 12. So x is going to equal 4 plus or minus the square root of negative 4 squared is 16, minus, let's see here, 4 times 12 times 5 is 240. And that's all over 24, because 2 times 12. So x is going to equal 4 plus or minus the square root of 16 minus 240 is negative 224 over 24. And for this one, negative 224 is not a perfect square, but I can pull out a perfect square. And that perfect square happens to be 16. 16 times 14 will give me 224. So when I go to write this answer, I'm going to have 4 over 24. I'm going to break it up because we want it in complex form. Plus or minus, we're going to break up the square root of negative 224 into the square root of negative 16 times the square root of 14. So it's going to become 4i square root 14 over 24. And then the last thing we can do is we can simplify those fractions. 4 over 24 can simplify to 1/6 plus or minus, and then the 4 over 24 again can become 1/6, so I square root 14 over 6 is our final answer there. I am going to erase this a little bit, so if you need to, pause the video and make sure you have it written down. And I'm just going to make a little bit more space over here. Okay, so now for B, you want to have your quadratic written in standard form, so it has to be equal to 0. So I am going to subtract 6 from both sides. And we end up with negative 5x squared plus 4x minus 6 is equal to 0. And so this will be A, this is B, and that's C. So we will have x is equal to negative 4, because it's the opposite of b, and b was positive 4, plus or minus the square root of 4 squared minus 4 times a, which is negative 5, times c, which is negative 6, all over 2 times negative 5. So it's going to give me x is equal to negative 4 plus or minus the square root of 16 minus negative 4 times negative 5 times negative 6 is equal to negative 120. So minus 120 all over a negative 10. 16 minus 120 is equal to negative 104. So now we have x is equal to, which I don't really need the x because I have it there. So negative 4 plus or minus the square root of negative 104 all over negative 10. And again, we do need to break that up and simplify. So it's going to be negative 4 over negative 10 plus or minus the square root of 104. I know that 4 will go into it. Let's divide and see. Yeah, 4 and 26. So we're going to break it up into the square root of 4i times the square root of 26. So that's going to give me 2i square root 26 over negative 10. And what I'm going to do here is those two negatives with the 4/10 make it a positive. So, and I can simplify that fraction. It becomes positive 2/5 plus or minus. And then we have one negative in the second term, but I can simplify the 2/10. So it's going to become negative I square root 26 over 5. And we do want to keep that negative with it, even though we have the plus or minus, because that is a negative right there. But that will be our final answer. And that is it for Module 2, Part 2. Hopefully, these were good examples and they helped you out.